Okay, so we're going to be using the correct math term for it. What's the correct term for spin? What should we say if I say spin? Not spin, but what's the correct term for it? Rotate. Nice. What's the correct term for flip? Not flip, but reflect. Yes, reflect. Remember, we can reflect left to right, which we care about what the X is, or we can flip top to bottom, which we care about the Y. And what's the correct way to say slide? What's the correct way to say slide? Translate. Okay. Okay, so first name and period. So yesterday we had the interactive activity that let us actually tell the computer what moves to make for us, and we got to see it happen. So if you missed yesterday, I recommend going to click on the link that's in yesterday's in-class activity. If it was an excused absence, make sure you've watched the video and fill in, because you still need to turn that in. You still can turn that in if it's an excused absence. But that way you can kind of play with it just like we did yesterday. So we are going to be describing, using the real math words now, how he moved his key A to spot B. From spot A to spot B. Okay, and he's doing more than one move to get it from spot A to spot B. Who can tell me a first move that he made? So this is sentences. We're not going to be doing any calculations. So what was the first move he could have made? Now, when we're talking about the stuff, we need to include whether we're moving horizontally, whether we're moving vertically, whether we're moving up or down, left or right. When we do our rotations, are we rotating to the right, which is clockwise, or to the left, which is counterclockwise? Okay, so what is one move? What's the first move Rowan could do to get it from point A to point B? What is the first move he could do? Okay. So his first move would be, okay, so how do we say that? What's the official word for slide? Again, what's the official word for slide again? Translate. So Rowan translated, and then we have to tell, we're saying that he slid, Rowan translated. What did he do? How did he translate? So could Rowan do an X direction and a Y direction at the same time for this situation? Well, remember what happens if we do X and Y at the same time. The X direction will happen first. If I move the key to the left, what's going to happen? What's going to happen if I move it to the left? I would hit the wall. So can I do a left and an X direction and a Y direction at the same time as his first move? No. So I don't disagree with someone saying that down was a good first move. I disagree with how they worded it. Let's use our math words for it. Okay. So Rowan translated. That's what we decided he moved, right? He slid, translated. Which direction, horizontally or vertically? Now, yes, it's true, Nautica, you could move backwards, but you need to be going left. So why move right to move back left? Okay. We translated. Nice, Leslie, vertical, because we're going up and down. Translated vertically. How many? And up or down, which direction? How many? 1, 2, 3, 4, 5, 6. Good. 6 down. Okay. 6 down. Okay. Which gets us y minus 6 happening. But are we changing the x at all? Did we change the x? If we just went down? No. So what would be happening is my x would stay the same, and we'd subtract 6 from the y. Let's see how that works. So what is our coordinate for spot A? And if you were noticing on the program, it was doing this for you. It was translating it into this for you. But what's the coordinate on this spot A? Okay, 5, 4. Okay, oops, don't need that. 5, 4 is this one. What's our coordinate on spot B? Let's get that one in here too. And I'm gonna make him blue because he's an ending point. What's our coordinate for spot B? -5, -2. Okay, so let's get that in here. -5, -2, right? So according to what we just did, we took our spot A and we didn't change the x, but we subtracted 6 from the y. So where would this A have moved to? Where would my new dot be for the A dot? If I did, don't change the x and subtract 5 from the y. Because we said down 6, right? So what would the coordinates be on our new spot? Let me put it in better. Okay. Our new coordinates ended up becoming 5, -2. Now, does 4 minus 6 make -2? So did we go ahead and go, the x coordinate stays the same, the y coordinate subtracted 6? Would that get us what we want? Which was the 5, -2? Yeah, it does. Okay, so when we're thinking about translations, we want to think about how are we changing the x? How are we changing the y? All right. So that got us to our first point here. Now, the way it works is they call the points the same letter as the original. So this is still spot A, capital A. But what they do is they use the little tick mark in the sky, and that's called prime. So this is called A prime with a little tick in the sky. It tells us we have moved A from its original location to a new spot. Okay. So that was his first move. What did he do next? Then, what did he do next? So we've envisioned that that key has slid to this location. Okay. The key is now in this spot. And I'm going to move this over here for a second. I'm going to fill it with white so I can see it. Fine, and I like that. It lets me do it. You work with me. Thank you. Okay, so now the key has slid to this location. So I'm going to make a screenshot of my key with my little feature. If you can do it, fine. Just take a screenshot of what you need, not the whole thing. I just need the picture of the key. And I'm going to go ahead and copy it over. I have to say that mine is old school. It's a laptop. And I'm going to come to my computer file, and I'm going to grab that screenshot, and I'm going to stick it in right here. Now, if you can't do that, it's fine. Don't worry about it. But it just made it so I could visualize what's going on. Okay, so now what do we want to do? We have options. Okay, remember, we need to get the big part of the triangle matching with the big of A, matching with the big part of the triangle for B, right? This is not the same size. I'm going to make it a little smaller if it lets me. Or not. That's the big size it's going to be. It's not the same size as it was before, but it's okay. So I need the large part of the triangle for the one I just pasted to match with the large part of the triangle over here. So what do we want to do to get it to look like that? Or do we want to slide it before we look like that? Does it matter? Because remember, ultimately, we can use the reflection to get us a rotation. We found that out. We can use the, we could slide first. We have options. So what options do we want to take? What options do we want to take? So we need to get this big side of the triangle to match with the big side of this triangle. And remember, like we said, there's more than one correct way to get it from here to there. There's no one correct, perfect way, as long as you get it there. You could take 10 moves if you want to. You could take 3 moves. You could take 5 moves. You could, however moves it you need to get it so it's the same direction in the new location. So what do we want to do now? Lily said she wanted to reflect. So let's check if we can reflect. First thing, how far apart is A and B now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember, when we reflect, it has to be an even number because we have to fold it over. We have to fold it over. So if we were going to reflect, are we reflecting left and right, or are we reflecting up and down? If we were going to reflect this, would we reflect left and right or up and down? Left to right. So when we reflect left to right, we look at what the X is that's halfway in between. Okay, so if it's 5 here and it's 5 there, it's a total of how far apart? If it's 5 here and 5, it's 10 apart. So halfway between would be 5 away from either side. So I could subtract 5 from the positive or add 5 to the negative, so it gets us into the middle. What would we get? What would we get? Subtract 5 from the positive x or add 5 to the negative x. That'll get us to the middle. So what's the x at the middle? X equals what at the middle? So we only worry about the x. What's the x equal at the middle? X equals 0. So he reflected over x equals 0. Now, what is another name for that line where x equals 0? What is another name for that line where x equals 0? It has the word axis in it. Which axis has x equal to 0? Which axis has x equal to 0? The y-axis. So you can say he reflected over x equals 0, or you can say he reflected over the y-axis. Okay. So if he reflects over the y-axis, he lands over here, right, at 5, -2. But is the key facing the correct direction? So I'm going to copy my key. And I'm going to see if it's going to let me reflect it. We shall see. So I want my key. No, don't go bigger. Over here, but it has to face the other direction. So let me see what I can do to get it to face the other direction. Nope. I can't make it reflect over. I can't fold it so it flips that way. Oops, no. So my key is here, but it's facing upward. So I'm going to put it like the dot's here, but he's facing the other direction. You guys understand that? Imagine the key flipped over. So the dot's lined up. Do we have it the way we need it? Is that the way our key needs to be? Okay, so remember the dots match. The big end of the triangle is on the same side as the big end of the triangle, but it's not in the same location, right? Because if I flip this key over, right, the big side would be facing up and we need it facing down. So what do we need to do? What do we need to do? What do we need to do now? Since the big side is facing up, but I need the big side facing down. Because remember, we're envisioning that this is flipped, so the dots are on the same end. We have to imagine. So the big side is facing up, but we need the big side facing down. Would that be a rotation? If the big side, remember this is flipped over, so the big side is here. So let me do this instead. I'm gonna take this off and I'm gonna attempt, let's go for it, to draw a triangle in here. Let me see if I can get one that I like. Nope. So we're going to hand draw it. Here we go. We currently have a triangle that's doing this because we reflected it left to right. Oh, I think I know how to do it. Okay, so our triangle, use lines. Our triangle is currently going this direction. But we want it going downward, right? That's what happened when we reflected it. Okay? So what do we need to do to get it so it's downward? I don't think spinning is going to fix that. What do we think we need to do? We can't rotate it. We need it to go from top to bottom, not rotate. What do we need him to do? Reflect again. Yes. So if we're going to reflect again, that's fine. What way are we doing that? How are we reflecting? The first time we reflected over the x-axis, the x equals 0. Okay? So he finally, because this looks like our last move, right? Reflected over. Now, are we reflecting top to bottom or left to right? Top to bottom. Which one of our letters moves up and down? Which one of our two letters moves up and down? The Y. So we have to worry about reflecting over a Y now. We have to worry about reflecting over a Y. Okay, over Y equals, what does the Y equal? So I flip over. We are at this spot right here. We are both at -5, -2. The problem is my triangle is not facing the right direction. Okay. My triangle is not facing the right direction. I need my triangle facing the right direction. So where would I fold it in half? What Y value would I be folding in half over? What's our Y? At our spot. Because that's where we're folding it, right? At the spot. Okay, so how would we say that? Y equals -2. That tells the person that we folded it where the Y was -2. Whenever we see this reflected, it means fold it, okay, at wherever they're telling us. At the X equals 0, fold it, which means I'm going sideways. At the Y equals -2, which means I'm coming down. Okay, so we did A to B. Now we have to do C to D. So we're going to be doing words again. So I am going to copy and paste my word set so then I don't have to type them all. I can just change the ones, right? We're now going from C to D. We're now going from C to D. Keep in mind how we have to get past it. We can't go through walls. We can't make parts of the key go through the walls. Okay. So what does Rowan need to do first to get from point C to point D? Could we reflect it? Where C is right now, could it flip over? Because the big end's on the left and we want the big end on the right. Could we do that flip yet? Do I have enough space for my key to fit if I flip it where it's at? because that key is 1, 2, 3 wide. Do I have 3 spaces before the wall? No. So we can't flip it yet, but we know we're going to want to, right? Because the big side is on the left and the big side's on the right over here. Okay. So what do we need to do instead? Could I spin it? And would spinning even help? Is there space to spin the key? And would spinning the key even help us any? What do you think? No, there's not space to spin it because again, boom, it hits, right? But, and does spinning help us any? No, because spinning would not make the slant be on the bottom. So we are going to need to reflect as one of our steps. But what do we need to do first to get us over to where D is? What should we do first? Since we cannot spin, since we cannot flip, what are we left with? We can't reflect, we can't rotate, so we have to do what? What's left? They're all at the top of the page if you have to look at it and remind yourself. We can't reflect, we can't rotate, so we can't flip and we can't spin because there's no space. So we must have to do what? Translate. We have to slide. Remember, if you choose to slide the X and the Y, the X will always come first. So while I do want to get the C to the right in the long run, because of this wall, I can't do anything with the X right away. Okay, so what do I need to do so I can make sure I'm above this wall so I can start sliding and moving and stuff? I have to translate which direction, vertically or horizontally, and how many. Vertically still, because I need to go up and down. Vertically is up and down. Horizontally, remember, would be the left and right movement, but we're going up and down. Okay, up and down how much? We need to make sure the key clears the top of the wall. So the key is how wide? How big, how wide, tall is the key? How tall is the triangle? I don't think it's 2 spaces tall. It looks like it just goes from here to here. So it looks like the triangle is 1 space tall because I can see the triangle over here is only 1 space tall. Okay, so whatever I do to spot C, I need to make sure I add 1 because the top of the triangle is below. So if I get C to the top of the line, how far is that? 1, 2, 3 would get me to the top of the line with the letter C. But I need to go 1 extra so the tail of the key makes it 2. So how much do I need to slide up? Okay. So we need to translate vertically. How many? And which direction? 4 spaces, which direction? Down? Or up? No, 4 spaces up. Okay, so we changed that piece of it. Which means, is my X changing? Did we change our X? If I slide up, does that change our X? No, so the X stays the same. But what are we doing to our Y? If we're going 4 up, what am I going to say happens? Y what? Up is which direction? Positive or negative? Positive 4. So let's look. What's our coordinate for our C? What's this guy right now? as is. What's its location? Yep, -2, -4. Okay, so this guy is currently at -2, -4, right? Currently it's at -2, -4. If I slide it up 4 and make my new triangle, right? I'm gonna make it a red dot. We said up 4 from -2, -4. So I'm still -2. -2 what? Where would the dot go? Yeah, -2, 0. So this is my new location for my C. This is C. And remember, we use, with the quote marks, there's the 1 and there's the 2. You're using the 1. That's what that little is. That's C prime. And we have our triangle. That's 3 long. See, it goes 3 over. 1 up. So here's where my new triangle is. Yeah, I want you drawing it. And we decided that new location was, oops, back up. 0, -2. Nope. -2, 0. Someone wrote it and then I just, okay, that's what we decided that new location was, right? -2, 0 is where we're at now. We need to get it over here to D. So what are we going to do? Can we now go X and Y at the same time? Do we have space to go to the left and right before we do an up and down? Yes. So we can now change, we can now translate to the right and down, right? Because we can do both motions now because there's space for the key to get past the wall. Okay, so what are we going to do? He's going to then translate. We're going to translate again. Okay, so we can slide him over and we can slide him down. So what would that be? Which direction is over? Horizontal or vertical? Which direction is over? Horizontal. Horizontal, how many and in which direction? Okay, which direction, left or right, how many? So you have to tell me left or right and you have to tell me how many. Okay, so if it's right here at this 2 and we want to get it over here, are we going left or right to go from 2? Because that's where he is, he's here. Let's put D's coordinates and maybe that'll help us. What's the location of D? What's its coordinates? 4, 2. Okay, so that'll help us a little bit see where we got to get to. We are currently at -2, 0, right? We need to get to -4, 4, -2. That's where we need to get to, right? Right idea, wrong thing, sorry. That works too. I did it backwards. Okay, so we need to get from -2, 0 to +4, -2. What do we need to do to get us there? Left or right, and how many? Up and down, and how many? I need both of those things. So we said horizontally, we're going to go sliding left and right. But are we going left or are we going right? To go from C to D, right. Okay. And then once to get from, we got to go from -2 to +4. That's where the person's coming up with the 6, right? 6. And now that we would be floating above it and down 2. Oh, and vertically down 2. Okay, that means what's our rule gonna say then? Our X number, what did we do to it? If we went right 6, did we add or subtract? If we go right, is that adding or subtracting? Is that positive? It's adding. So we added 6, and our Y is down, adding or subtracting? Is down, adding or subtracting? Think about it. Remember, it's adding if it's positive, it's subtracting if it's negative. So if we went down, did we add or subtract from our Y? Subtracted. 2. So our triangle, we're going to work smart, not hard. We're going to go copy and paste the triangle I drew over here. Our triangle that we made here has now slid to here. Is that going to work? Is that going to work? Sliding it like that? Could we move our triangle like that? Really? Seems to me like that triangle's hitting a wall. I don't see that he slid down because I don't see that there's space. There's a wall there. So can we do both a left and right, up and down right now as the second move? No. So which one can we do and which one can we not do? What was the move that was a problem? The left and right or the up and down? Which move was the problem? The left and right or the up and down? The up and down. So we have to take the up and down back off because we can't actually do it yet. Oops. So we have to back ourselves up. We can't do the vertically down 2 thing. Okay, we can't do the vertically down 2. It won't let us. There's not space. Okay, so we have to take off the vertically down 2 because when we went ahead and moved it, it didn't fit. right? So did I change my y after all? No. So my triangle is now sitting here. So we put 2 of the tick marks because we've moved it. What's its location now that it's sitting here? Once we move it right. What's its location? What's the coordinates I should change this to? That's no longer a -2, 0. What is that point? What is this new point that we move the triangle to? What do I want to change this -2, 0 to? Where is it at? It's not at -2, 0 anymore. Where's it at? Oh, 4, 0. Thank you. All right, so we changed this to a 4, 0, and we're sitting here, right? We're sitting at this spot. I am expecting you to be drawing the stuff in when you do your homework, just like we're doing now. So you need to be practicing that. All right, what do I need to do before I can slide down then? Since I couldn't slide down right now, I would hit a wall. What do I need to do instead? What does Rowan need to do instead? Because he can't just slide it down from where it is. There's a wall in the way, right? There's a wall in the way. So what does he need to do instead? Okay, reflection. He needs to flip it. Yes, 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 yes. Right. Okay, so he needs to flip this triangle, right, that we have. We have to flip the triangle. We have to make it go left or right or up and down. Which way does he need to flip it? He needs to reflect it. Okay, so are we reflecting left and right or up and down? We're reflecting left and right. If we reflect left and right, we're folding it hot dog style, right? Hot dog style. So if I fold it hot dog style, is that folding a Y line or is that folding an X line? Because left and right, is that your X or is that your Y? Is left and right your X or is left and right your Y? It's the X. So we're folding it hot dog style. We're folding it on the X line. Which X line are we folding it on? Not the Y-axis, because we're not on the Y-axis. Y-axis will be when X is 0. What is our X equal to? So we're folding our line on. 4. Yep. Okay, so now his triangle. We'll draw our triangle in. 1, 2, 3. Down 1. Connect the dots. Is it now going the right direction? Is it now going the right direction? Yes. Can it slide now because it has space? Yes. So what's our fancy words for slide? He finally is going to be doing what? Slide is not called reflected. Slide is what? Translated. Which direction, vertically or horizontally? How many and which direction? So is he translating up and down? Because that's vertical. He's translating left and right. That's horizontal. So is he translating vertically or horizontally? Vertically. Okay, so he translated vertically, meaning up and down. Which direction and how many? Down 2, not -2, down 2. So let's look what it's doing to our rule, right? Are we changing the X for the location we're currently at? Are we going to change this for? No. So we're keeping the X the way it is, and we're changing the Y by doing subtract 2, just like he said, -2, 2 down. Okay. So the first thing that we did is we added 4 to the X, added 4 to the Y, but didn't change the X. Then we added 6 to the X, but didn't change the Y. And then we flipped it, and then we slid it down, subtracted 2 from the Y, but didn't change the X. Okay, so these little parentheses are what's happening as it slides. This says keep the X the same, slide the Y4 in the positive direction. Slide the X6 in the positive direction, keep the Y what it is. Okay, keep the X the same, slide the Y down too. Okay, that's what those little rules mean. And if you have been looking at what the program was doing yesterday, it was doing that for you. Okay, now, says Felicia found a copy of a puzzle like the one from the lock and key, right? But the lock is missing. All she has is the starting point and the moves that the key took. Okay? The starting point and the moves the key took. So we are going to we're going to make the triangle, we're going to move the triangle, and we're going to see where it ends. Okay, so I need to zoom out a little bit because I can't see those and the graph at the same time. So you have it on your page, just like I have it on mine. Okay, so we are going to graph the triangles. The first thing we have to do is we have to graph the original triangle. Okay, so the original A says -5, 0. So I would go get my points, and I would go -5, 0. That is where my A is going. Okay, then it says to go, B is at -5, 3. So -5, 1, 2, 3. There's my B location. And they are capital letters. Please make sure they're capital letters. And then it says C is at -1, 0. So -1, 0 is back down here. And there's my C. Okay, and I'm going to connect them to make the triangle. I'm going to connect my points to make the triangle. Even though this has a solid line, make sure you do it because we're going to copy and paste the triangle. You need all 3 of its sides drawn in. Okay, and then we're going to go put the coordinates on each one. B, I'm going to put the B in with it now. B was at -5, 3. I don't need this one anymore. Right? A, just going to change what I got. Work smart, not hard. Is at -5, 0. And then C change that one up, is at -1, 0. Everybody okay and understand how we just made the triangle? Anybody have questions about how to make the triangle? All we did was plot the 3 points they gave us, connected them with lines to make the triangle, and labeled where they were at. And I'm actually maybe going to put C on this side. So it's definitely looking like the point. Okay. Okay. Get that triangle made. We might actually get done in class with time to start your homework if we can get this done. Plot the 3 original points, A, B, and C, then connect them to make the triangle. And then I'm going to go take the triangle. I'm going to copy and paste as it moves around so that I don't have to reinvent the wheel. Okay. So I'm going to paste one over here for myself so it's ready to use. The first move it says that happened was what? Translate. So is my triangle going to change any directions if it translates? Does translate change what direction the triangle is facing? Does translate change what direction the triangle is facing? Because translate is slide. Does that change what direction the triangle is facing? I'm going to copy him in a second. I don't want him yet. Okay. I need you guys responding. If I say translate, does that change which direction the triangle is facing? When we say translate, what does it mean is happening? What motion is taken? What motion happens with translate? What motion happens with translate? Because I want a definite. I don't want a question mark. I want you guys making sure you understand. What motion happens with translate? What did we call it yesterday? Slide. If I slide it, is that going to move where the top of the triangle is when I slide it around? No, it does not change that the top of the triangle is at the top. That's what I'm talking about. Did the top of the triangle change where it was? Did the point move to the left? Did the point go down? Did the point? So slide doesn't change how it looks. So we are going to copy the triangle we have and slide it to where it tells us. Okay, where is it telling us we're sliding to? Where does, what slide directions does it tell us? What are our slide directions? What does it say? Motion-wise, we're supposed to translate. Where are we moving? How are we moving? Okay, 4 to the right. So my A, which currently is at -5, 0, right? They told us to make the new one, we're supposed to go 4 to the right and up 3. So I'm taking my original number I have, okay, taking the original numbers we have, -5 and 0, right? And I'm moving them 4 to the right, which is adding 4, and up 3, which is adding 3. So where is that going to make us land? If I take -5 and I add 4 to it, what's the new location? It says take -5 and add 4 to it. What do we get? Are those the same sign? So if I go -5 plus 4, what am I going to get? Because we're going to get the locations and then we're going to go plot the locations. But if we don't spend the time to get the locations, it's really hard to do. So -5 plus 4, what do we get? What would our new coordinate be? If we take our x, -5 and add 4, if we take our y and add 3, what would the new location be? Do the math. -5 plus 4 is not 9, but I do agree that the y is 3. Oh, -1, 3. So we're going to do the same thing for b. We're going to take the original b, which says -5, +3, and we're going to add 4 to the x and add 3 to the y. So my existing x was -5, my existing y was 3. So what would the new location be? Not -1, 3, -1 what? Because I started at 3 this time. See, it's a -5, 3 at the start. 3 plus 3 does not make 3 still. So what are we going to have? -1, comma what? -1, comma what? 3 plus 3, what do we get? -1, 6. Okay. Now we have to do C. What is C's existing location? Should say B, sorry. What is C's existing stuff say? That's what we always list first. Where is C at right now? -1, 0, right? And the rule says take the x, -1, add 4, take the y, 0, add 3, make the new location. So what's the new location? If I go -4, -1 plus 4, I'm not still -1. What am I? So you take the existing location and you add or subtract what they tell you. Going to the right, I add it. 3, and then 0 plus 3 is 3. Yes. So these are our 3 new spots. So we're going to go graph those. And I'm going to change to red so I can tell apart. So this says I'm at -1, 3. No, that's 2. Back it up. -1, 3. I can do it. Then it says that I'm at -1, 6. Then it says I'm at +3, +3. I have now slid the triangle, but this dot's in the wrong location. 1 second. That's 5, not 6. There's 6. I've now slid the triangle to here, and I'm going to connect my lines to make my new triangle in the new location. Okay. And it's the same as our old triangle in every way, except we slid it. We translated it. So it should be the same size, be facing the same direction, be the same shape. Everything should be the same, but we slid it to a new location. Okay. And we're going to go get those new locations. I'm going to borrow the coordinates from A before. But I'm going to change them to the new one that was -1, 3. And I'm going to put 1 tick mark on my A, because that's where my A is now. It's in a new location. Okay. Do the same for the B location. Do the same for the C location. Do the same for the B location. So copy and give it its new address that we figured out over on the side. Okay, so my B is now B with 1 little, right? And it is at -1, +6. Okay, and then we got to get our C, and we've got to change it to its new address with the numbers that we changed over on the side. Okay, which happens to be +3, +3. Okay, there's translate. We slid it. Nothing changed. Okay, it didn't change direction. It didn't do any of that. Okay, so that's translate. Now it says we need to reflect, right? Step 2 says to reflect. So when we reflect, that's our flip, right? Which way is it telling us to reflect? Across the what? Across the what? X-axis. So which one of the lines is our x-axis? The one that says X on it, right? The sideways one. So if I'm going across the X-axis, is the paper folding? The paper folds on that line. So we're going to fold the paper on that line. Is the paper folding top to bottom or left to right? If I fold it on that X-axis, which is the one that's going sideways, is my paper folding top to bottom or left to right? Okay, and one of the ways we know, if I fold, because remember, This line right here is my x-axis. That line that's going sideways, right there is my x-axis. If I fold that line, am I folding top to bottom or left to right? If I fold that line, this is the line that the paper's folding on. Top to bottom, because the line is going sideways, I have to fold down to fold that line, right? Okay, so when I fold down, when I reflect down, do I worry about a y equals or an x equals? If I fold it down, which is going to be changing, the y or the x? Which one goes up and down? The y. So this says that we have to reflect on the x-axis, right? Which is when y equals what? What does y equal on this line? We put a dot here, what did the y equal? We put a dot there, what did the y equal? What's y equal when we're on that line? What did y equal for these ones that had the dots on the line? What did the y equal for their coordinates that have dots on that x line? What is another way to say the x-axis? Y equals what? And I know this is harder because we don't get to use the tool and see the tool move it. But we're learning how y equals 0. That's right. So I need to figure out for each of my spots, A, B, and C, and this C should have a little on it because it was a movement. For each one of my spots, how far is it from that line? Because if I fold over it, it's going to be that far past the line. So if we envision the paper, let me get paper. Right now we have our graph, right? And we're going to fold it down, right? So however above the line it is, it's now going to be below that far, right? For every single one of our spots, for the A, the B, and the C. Every single one of them is going to flip that same distance down, okay? Because we're folding it down. So I'm going to take my spots, this stuff up here, and I'm going to use them to flip. Okay, copy, put it down here. Oops, right idea, wrong thing, try again. Copy, paste, move it to where I want it. I'm going to take off this word that say translate. We don't need that. We just need these bars. Okay. Right? We need this information because if I flip it down, is my X going to change? If I fold the paper down, does the X change? If we fold the paper down? No. What's the only one that's changing if I fold my paper down? The Y. Now, what's the Y doing? So this says it's 3 above, right? If I fold it on the X line, it will now be 3 below, right? So I'm starting with this location here, where we were at. We're using our second spot, our A prime. Okay? We need to fold it down. The X isn't changing. The Y is becoming what though? If I have to keep it the same distance from this X line when I fold it down, what happens to the Y? So I have it and I fold it down And however far up I was, I have to be that number down, right? So when I'm going over the x-axis like this, doesn't it mean that the y is just changing sign? If I'm going over the axis? Because this A says 3 above. So the new one has to be 3 below. This B says 6 above. So what do we think this one has to be? If my original one is 6 above and I fold the paper down, the X doesn't change, but the Y is going to become what? 6 below. So what would we say? What would we say? Six below. Come on. Remember, when we're folding on one of the axes, it's just flipping signs. Just flipping signs. So who wants to venture to flip C? C right now is at +3, +3. But we're folding it down, so it becomes what? +3 what? Because the X's are not changing. And we folded it down. So it's not a +3 anymore. What's it going to be? Because we went across the x-axis, we just get to flip the sign of the y. So what am I going to flip the y to? Not +3. What are we going to flip the y to? Not +3, because we flipped. What are we going to flip it to? -3. Okay, so when we jump over axes like that, the x-axis or the y-axis, all we have to do is flip the one we're not changing. Okay, keep the one that doesn't change, flip the one that does. So we have 3 new locations. Okay, we have 3 new locations. We have to graph these new ones. -3, -1, +3 turned into -1, -3. So we'll get my dot. -1, -3. -1, -6 for the B. And +3, -3. Oh, I went to 6 and should have +3, -3. Okay, sorry. There we go. Okay, connect our dots. Did we do all 3 things that it asked us to do yet? No. What do we still need to do? According to the rules, we did a translation now. We did a reflection. What was the third move that they wanted us to do? What was the third move that they wanted us to do? Rotate. So let's get this one in here. Okay. I'm going to go take these coordinates that I have here. There's my A. But now it's A2 ticks because we did 2 moves. And I'm going to put it in my A spot and then take out the extra stuff. Give me a second. I don't need the stuff in between. And I have to put a second tick on it. There's my A. Okay. Now I got to go do the B. I'm going to take the B. Copy it over. Get rid of the stuff I don't need. Put the second tick on it. A little white. And then my C. Okay. Second tick on it. Get rid of the stuff I don't need. Fill it with white so we can see that it's here. Okay, now by far, this one is kind of the trickiest one. Okay, the rotation. The rotation. What is it telling us it wants us to rotate? Which direction? Counterclockwise, which means left. So things that used to be on the right, it says rotate how many degrees? How many degrees? 90 degrees. So that's just one tick. So it's from sideways, it's going to stand up. Our triangle is going to stand up. Okay, our triangle is going to stand up. All right. It's going to stand up, and it tells us what location we need to do that from. From location +2, +3, -2. So I'm going to, in green, put my dot, and I'm going to make it stand out more. I'm going to give it a 6. Where they told us to spin around. They told us to spin around +3, -2. So +3, -2. Into this original C. Okay. That green dot is where we're going to be spinning. Okay. We have to keep ourselves anchored to where that green dot is. Okay. We have to spin on this green dot. So if I spin to the left, I'm currently, okay, so here's my cup, that's the dot. I'm currently down here, right? I'm below my dot. So if I do one spin, I'm going to come even more below my dot. But I'm going to change what was left is now going to become top. Okay, so this is where it gets the trickiest. Okay, we are going to spin it so it stands up below the dot. We're going to spin it so it stands up below the dot. All right. That is the hardest one, the rotation, because you can't actually physically do it. So I need to stand it up below the dot. Whatever is on the side is now going to go up. Okay, whatever's on the side, this 3, -3, it's on the side right now. It's going to become the top. So it's not going to change. But this A and this B, they're going to come around. They're going to spin around. Okay, so what I'm going to do for this one is I'm actually going to draw it in first. Okay, so that I can see it. I'm going to draw it in first. And then I'm going to find the location of the corners. So my A is going to spin around. How far apart is the A and the C? Because it still has to be that far apart. How far apart is the A and the C right now? Four. So I need to make my A 4 below. 1, 2, 3, 4. This is where my new A is going to be. Oops, I want that to be red. This is where the new A is going to be. Because it's spinning, right? It's spinning down, but it has to stay the same distance. 1, 2, 3, 4. How far apart is A and B? It has to stay the same far apart. So how far over am I going to put my D? How far apart is A and B? Because now B is going to be over here. 3. So 1, 2, 3. So for the rotation, it's easiest if you draw it first, making sure that you keep the same size lines as you had before. It's just going a different direction. Now, is our C location changing? No. No, it's not. Are the A and B locations changing? Yes. So I need to go grab the A and figure out, where is it now? Where is it now that we moved it? And this is 3 slashes in the sky. Where is it now? Let's finish this. Where is it now? Is the A still at -1, -3? No. Where is the A at now? 3, -7. Thank you. Okay. B. Is the B still at -1, -6? No. Where'd the B move to? It's no longer -1, -6. Where's it at now? Is this +7? No, it's supposed to be -7. Sorry, I typed that wrong. 6, -7. Exactly. Give me 1 second. We almost got it. 6, -7. And he's going to get 3 tick marks. So then it says, where did Felicity's triangle end? Now that we've drawn it in here, we're going to answer the last thing. Felicity's triangle, I appreciate you guys sticking with me. Felicia's triangle ended at, and then we're going to go grab these 3 spots. Oops, I forgot when I copy into this, it doesn't like that. 3, -7. At B, 1, 2, 3. Oops, not bookmarks. 1, 2, 3. 6, -7. And C, 1, 2, 3. What's that? 3, -3. Okay? All right. It is done. Turn it in. Okay? Have a great day. I appreciate you guys sticking with me so we could finish it up. So that's what we have to do with our homework. Have a great